is my heartbeat song and I'm gonna play it. Been so long I forgot how to turn.
Alright, there's my introduction for today then, because we are going to be talking about heart actions. Blood pressure, EKG, so the little at the beginning of the video you see the bleep of an EKG and then the flat line at the end. So we will be able to read an EKG and tell how much of your heart is resting, how much of it's working, and that'll be something that will be on the test that you'll need to actually calculate. So cardiac cycle consists of your atrium that are going to beat in unison. So your heart beats top, bottom. So your atria are going to beat together, and that's called atrial systole. So your atriums are contracting. Followed by the contraction of both ventricles, ventricular systole. And then the entire heart relaxes for a brief moment, which is called diastole or diastole, diastolic, you'll also hear quite often. So that relaxation is very important for your heart to have that moment where it can actually rest. So as all of this is happening, your blood pressure changes depending on the strength of those contractions of your heart. If you take your blood pressure right now, take it 5 minutes from now, another 5 minutes, it's not going to be exactly the same because it changes, it rises and falls a little bit quite often. When the atria fill, so blood is being dropped into the top of your heart, the atria pressure is greater than the ventricles. The ventricles are empty, the atrium are full. So that forces those AV valves to open. So blood is sitting on the top of the heart, pushes those valves open, and it's going to fall into the ventricles. Pressure inside the atria rises further as it's filling with blood. As they contract, and then that forces the remaining blood into the ventricles. So basically, first your blood falls from top to bottom, and then there's an extra squeeze that pushes out the extra blood that's still inside. So then the blood is in the ventricles, and your ventricles are going to contract, which is going to increase the pressure inside of the ventricles. And when they squeeze, it pushes the blood upward and outward, and that forces the AV valves to close. And that's what we want because we don't want the blood to come back up into the atrium. When that happens, the aortic and pulmonary valves open because those are the valves that are coming out of the ventricles. So the ventricles contract, papillary muscles that are hooked to those chordae tendineae pull on those chordae tendineae and prevent backflow. Atria are then going to start filling again, and that cycle is going to continue and continue. So atrium to ventricle, out of the ventricles, back into your atrium. As the blood is pushed out of the ventricles, the pressure drops because they're becoming empty again. And then drops more as those ventricles completely relax. So when the ventricle pressure is lower than the blood pressure in your aorta, so that means that the blood is now left, it's in the aorta, the semilunar valves are going to close. So basically, once the blood has passed through the ventricles, passed through the valve, the blood's on the other side, that pressure is going to force those semilunar valves to close. And then once the ventricle pressure is less, the AV valves are going to open again, and the process, like I said, starts over. Falls back into the atrium. Atrium's going to have higher pressure, and so on and so forth. So here I can see if these are in, the atria are in systole, which means they're contracting, they are pushing blood into the ventricles. So when blood is coming into the ventricles, my semilunar valves, my pulmonary and my aortic valve, are going to be closed. because blood's coming in, it's not ready to come back out yet. So when the AV valves are open, semilunar valves are closed. Blood comes into the ventricles. Squeeze down, now the bottom's full. When the bottom is full, the pressure in here causes these valves to open, so the semilunar valves open, the AV valves are going to be closed. And those valves closing is really what causes your heartbeat sound. So the lub-dub is these valves closing, these valves closing. That's what you actually hear when you listen to somebody's heart. So heart sounds are due to vibrations as those valves close. Lub-dub, different, thump-thump, however you want to talk about it. The first sound occurs when those AV valves close. So in between your atrium and ventricle. The second sound then is when your semilunar, your aortic and pulmonary valves close. An abnormal heart sound, a heart murmur, we've talked about this a little bit before. If you have a heart murmur, which is fairly common, it's due to some type of valve damage. And like I said, you might have a little bit of backflow. If you have a severe heart murmur, they'll actually have to go in and do repair or replace the valves. But typically, a small heart murmur is not that big of a thing. This diagram just kind of goes through how much blood is where. So if I look at this closely, here I can see the ventricular volume. Okay, my ventricles are full, they empty out. They fill, they empty out. The pressure, I can see pressure changes. So if I'm looking at my ventricle again, not much pressure, oh, lots of pressure. Not much pressure, lots of pressure. Here is my EKG, and we're going to look more at this. So the PQRST waves, I will want you to be able to label those and measure those. But I'm going to explain that on a better diagram. So what happens to make your heart beat and make sure that it beats appropriately, consistently, there's a mass of fibers that merge together and act as a functional synctium. Basically what happens, one is atrial and one is ventricular, and they are going to be separated by the fibrous skeleton of the heart. So those merging fibers act together as one unit. And then what happens is there's specialized tissue in your heart that conducts nervous impulses through the myocardium, which is basically the muscle of the heart, and compromises cardiac conduction system is the system that works with your nervous system to fire your heart to beat. So in your heart, you have a self-exciting mass of completely specialized, only spot in your body, specialized cardiac muscle called SA node. That's the most common term. SA, sinoatrial node, but SA node is a common term. Also called the pacemaker of your heart, which is why if you have a pacemaker put into your heart, it is replacing the job of the SA node. So in the top part of your right atrium, kind of top back, there is the SA node, and that generates the impulse that starts your heart to beat. And if that does not work properly, your heart's not going to beat properly. So impulses then spread to this merging fibers, the atrial synctium. It contracts the atrium. Impulses travel through these fibers, and then it's going to go to the AV node. atrioventricular node, and that's located in the septum of the heart. So basically it fires from one node, those fibers surround the atrium, then it goes to the AV node, and that's going to spread throughout the rest of the heart. So these junctional fibers are small. They allow the atria to contract before the impulse goes to the ventricles. So that's why your top contracts first, ventricles second. The delay, there's a small delay through these fibers, allows both atriums or atria to contract at the same time. Then it goes to the AV node. From the AV node, the impulse passes through the AV bundle, which is another bundle of fibers, and travels down the in between ventricles, interventricular septum. Purkinje fibers branch off of that bundle, and they lead into the walls of the ventricle and the papillary muscles that are inside of your heart. These fibers then simulate contraction of the papillary muscles, same time as your ventricles, and that's going to cause the contraction of your ventricles. So picture, this is where it kind of all comes together. SA node, top of your right atrium. Remember when you look at diagrams, they're backwards because my heart is actually facing this way. Right side of the heart, left side of the heart. So AV node sends out impulses to the right atrium over into the left atrium. Atrium's going to squeeze. Then my AV node sets right above the septum in between your ventricles. It's going to fire. AV bundle is the first part where it's still connected together. And then you have your right bundle branch, your left bundle branch. So it branches off to each side of the heart. So this main branch comes down, and then the Purkinje fibers are the ones that are going to come up and lead into the inside of the ventricle and into your papillary muscles. So that diagram is also good to know the order and how that works. And last thing that I'll probably show for this part, this just shows the order. So if you look at the picture right before this slide, this goes with the order that it goes through. And that should make sense.